Good day and welcome. Our job today will be to work out the length of the diagonal lying across this box, the red dotted line. We can use the rules of basic Pythagoras to help us with this by creating a right-angled triangle that looks like this. Taking a closer look at this triangle, we know that we will need to work out the hypotenuse of our triangle. So we will be using this formula to do that. But whatever variation we choose to use with Pythagoras, in order for it to work, we will always need to know at least two of the sides. Looking at the height of our cuboid, we can see that it's the same length as the height of the triangle. So we can insert this as our first missing value. But that's as far as we can get, as there's no way at this point to determine the base length of our orange triangle. To make it this easier to follow, we will call this value y and remove some of the unnecessary information. Focusing just on this y value and changing our perspective slightly, we can see that looking from the top, we can create another triangle which also has y as one of its sides. And it is also a right-angled triangle. For this triangle, we already have the base, and we can use 9 as our height. Plugging these values into our formula, we work out the hypotenuse and the y value. Now that we have 15 in the base of our orange triangle, we can return to the original formula. Inserting this as our missing value, we can square 8, square 15, and add them together. Square rooting this answer will solve the problem and give us the missing value of x. There is a shortcut. If we have a look at the problem now that we've completed it and now that we understand what we're doing, we can see that in this formula on the right, which is the shorter version, x squared plus y squared gave us the 15. So instead of doing these as separate steps, we can just do them once off. So we can say 9 squared plus 12 squared, and then add the height, which would be 8 squared. Square rooting all of that results with x having exactly the same answer as before, being 17. Here are two problems for you to try. The first one is very similar to what we've just done, so a good warm-up problem. But the second one is a real test of your knowledge, because you're going to have to think and apply what you know to solve the problems. If you want to give it a try, pause the video now. We start by working out the base of what was my orange triangle by adding the 5 squared and the 4 squared together. Square rooting that, we get that y value. From there, we can plug it into our orange triangle, use it as the base. So we have 6.4 squared plus 3 squared, and then square rooting that answer, we get where x is 7.07. This next problem is a little bit different. Here, they've given us the red dotted line, the one that we were wanting to work out initially. So now we have to work backwards. So if we've got the 12 and we've got the height the same as before, we can use one of the other variations of Pythagoras and use the hypotenuse and take away the height value. So 12 squared minus 6 squared. And then square rooting those values, we will get the base of that triangle. Now that I've got that value, once again, changing my perspective and looking down from the top, we can start to see that we need to use the 5 from the base of my cuboid. And once again, the 10.39 is my hypotenuse. So if I take that squared and I minus my 5 squared, I will get the final answer that I've been looking for, 9.11. I hope it helped. If it did, give us a like and consider subscribing. We'll be adding more and more videos like this aimed at helping you ace your maths.